Hi, in this lesson, you're going to learn about some basics of sets and Venn diagrams. A set is a collection of objects. You might be wondering, what are these objects? What do you mean by objects? These objects that belong to the set are called elements. And these elements have specific characteristics depending on the set. Give an example of set builder notation. So set builder notation is like it says it, you're building the set. And a set is denoted by these little curly braces. So you start with that, and then you're defining the elements in the set. So we'll call them X. So this is telling the reader we're talking about X, such that, and such that is this long line. It's longer than the rest of your font, the rest of your words in the set. I can't think of the word. Such that, we could do anything here, but I'll just say X is an even number less than 8, and then close the set. That's set builder notation. You have to have the little curly braces to show that it is a set. You name the variable X, and then you describe the variable such that whatever. And you can use anything here. It doesn't have to be X. It can be A, B, C, Y, Z. It can be anything. And in words, just so that when you're going back and looking at notes, you can remember how we said that. So X such that X is an even number less than 8. So this would be, for example, 2, 4, 6. That would be listed out. The set would be listed out. What is an empty set? An empty set is a set with nothing in it. A set with nothing in it. And we write it with a circle and then a slash through it. That means empty set. We are going to list out the elements in each set. So it's going to look like this for list form. The set of counting numbers between 9 and 17. Counting numbers. So if you think about just counting, you say, 1, 2, 3, and so on. They're counting numbers. So it's entirely difficult. So if we're listing that, between 9 and 17, 10, 11, 12, 13, 14, 15, 16. That's all at once. Super simple. And then give a complete list of the set. Okay, so we've got a list, and inside the list, there's an ellipses. Ellipses means that it's going to continue in that same pattern. And so to complete that set, if we were to list out all the elements in the set, we just list what those understood elements are. After 8 comes 9, 10, 11. And they usually use this in the case where there's a lot of elements in between, and you see the pattern and you know that it continues in that manner. That way you don't have to write it all out like we just did. Then X such that as X is a counting number between 6 and 7. A counting number between 6 and 7. Now there are numbers in between 6 and 7. They're called rational numbers, like 6.1, 6.2, 6.5, 6.7, 6.75. There's an infinite number of numbers between those. But if we're talking about a counting number between 6 and 7, well, there's not one. So this would be an empty set. There's nothing there. What does it mean for an object to be an element of a set? So for something to be an element of the set, that means that an object lives inside of the set or belongs to the set. The symbol for element is kind of a little C with a bar in the middle. It actually looks like an E, element. And then for something that is not an element, we still have the little E, and then you just put a slash through it, and that means not. Pretty understandable. State whether the following are true or false. In number 1, it says 5 is an element of 2, 4, 6, 8. Does 5 live in the set? No. So this is false. On number 2, it says 0 is not an element of 1, 3, 5, 7, 9. Does 0 live in the set? No. So for it to say it is not an element, then that's true. And that's all you have to do for element and not an element. A universal set is basically the collection of all possible elements that we're discussing, basically. So you may have, you'll see down below, we'll have like a universal set, and then we'll have subsets, so smaller sets that we make out of the universal set. So that's kind of where that's leading. But the universal set is the set of all possible elements, either up for discussion or being considered or being looked at. Anything like that would work as far as your notes. Set of all possible elements under consideration, I'll say. And the universal set is not, there's not one universal set. It just kind of depends on what we're talking about. So if I were to say the universal set is fruit, then that would include all possible fruits, which would be really hard to list out, but you get the idea. So it just kind of depends on the situation. So you could be talking about odd numbers is the universal set, or fruit, or vegetables, or animals, or mammals, or whatever. So it just depends. There's not just one. And then a Venn diagram is typically, it's got like a rectangle, and then it has some circles inside. It can be any number of circles inside, but these circles are going to be overlapping. So it's just shapes, basically. It's a rectangle, which represents the universal set, with overlapping circles or ovals or whatever. These are subsets inside the rectangle. And down here, I have drawn out a few of those, or an example of a Venn diagram. It's the same one in each column, but this is a Venn diagram, V-E-N-N, Venn diagram. And we have this rectangle, and this rectangle represents everything under consideration. So that rectangle is U. And there can be elements listed outside in U that are not in these circles. So it may look different depending on what we're talking about. So if it were like, if I went with my original example of fruit, I could say the universal set is fruit. And then I could say set A is red fruit. And set B is, I don't know, green fruit. And then since I said that the universal set is fruit, then I still have orange, pink, black, all different colors of fruit, and those will be out here. So that's kind of the idea. We have some different operations that we can do with sets. And there's more than this, but for the sake of this lesson, these are the only three we're going to look at. We have the intersection, the union, and the complement. An intersection is what you would think it is. Let's think about roads. If we're talking about roads and you're at an intersection, that's where they cross, right? And it's usually, there's a stop sign there or a stoplight or something, there where they intersect. And so that is where two or more sets overlap. It's where they cross. And the symbol, the mathematical symbol we use for intersection is this upside down U. So in math, we like to not write so much, and we use a lot of symbols. As you've already seen today, we use a lot of symbols to shorten that. And so we would write A intersect B. And that's how you read it. A intersects B. And in Venn diagram form, that intersection represents the overlap in our Venn diagram. So the only place that there's overlap is here. I'm going to make that a little bit smaller. Here, this overlap in the center, that is intersection. So where A intersects B is there in the middle, where they have elements in common. They have the same elements. Then, I guess I could say that up here, where they have elements in common. And then union, the union is a collection of elements in two or more sets. So if you think about if you move in with a friend or move in with your husband or wife or whatever, you have a union where you're moving together and you bring all of your stuff and you put it together in one house, right? And you may have some elements that overlap. You may have two casserole dishes, you may have two rice cookers, you may have two recliners or whatever. So there may be an overlap, but the union is just collecting everything into one set. And the symbol we use for this is very simple. It is a U for union. So A union B. And that is less restrictive than intersection. The intersection is only the elements that they have in common, and the union is just the collection of all the elements in both A and B. We just collect them all up together, and some of them overlap, and that's okay. That's union. And then complement, if you think of complement, this is not the type of complement where I say, oh, you're really pretty. This is a complement with an E right here. This is when something complements the other, that means that it's basically kind of the opposite. So red complements green, or blue complements orange. They're opposites on the color spectrum. Or me and my husband, I'm short and brunette and I have hazel eyes, and he's tall and blonde and has blue eyes. So he's very much my opposite. And we're also complements in personality. So that's kind of what complement in real life means. And we can apply that to sets. So complement is every element in the universal set that a set doesn't have. So if I say the complement of A, then I'm listing everything outside of A, everything that A doesn't have. And there's two symbols for this that I've seen You can do a little apostrophe, or I've even seen a little C instead. Both of those are fine. I think this one is a little more popular with the apostrophe. So if I do the complement of A, then that's going to be everything, whoops, meant to do a highlighter, everything outside of A. That would also include everything in the universal set too, but for the sake of the Venn diagram, I'm just going to color that side just to make it a little better. I guess technically we could color everything out here also, since I have different colors. That'll be fine. Those are the set operations that we're covering in this lesson. So hopefully the visual helps. I did not mean to do that. The visual helps you see what we're talking about there. And that can help you in examples like the one down here as you figure some stuff out. So we've named the universal set to be these letters: A, B, C, D, E, F, H, I, J. So there's no G. Okay. And then we have these subsets that are all elements in the universal set. So they were made up of pulling, specific pieces from the universal set. And sometimes it can help. So let's pretend like this is your homework, this down here, and you're having a hard time seeing, where the intersection of A and B are. Now, obviously you can go up here, you can look at A and B, and you can figure out the elements that they have in common. And that's not too bad. But sometimes it helps to just go ahead and draw a Venn diagram, and then we can remember the shading to help us build our sets. So we go here to a Venn diagram. We actually have 3 sets. So we're going to have 3 circles. I'm going to have A, B, I should have done them bigger, but it's okay. C. That got oval. C. There we go. A, B, C. That's supposed to be inside the universal set, but it's okay. And then I want you to pause the video. I want you to fill out the Venn diagram, and I want you to remember that this overlap represents what they have in common. So this overlap is the overlap of A and B. This overlap is the overlap of A and C, B and C, A, B, and C. So I want you to try to fill out the Venn diagram, and then also, if you can, answer these questions below based on the Venn diagram. Pause it, try it, and come back. Filling out the Venn diagram can be a little bit tedious, especially with 3 sets. It makes it a little bit harder. But if you notice up here, I marked out the elements as I used them. So I methodically went through, I looked at A, and I saw that B also has A, and C also has A. So that goes here in this very center where all 3 sets intersect. And then I went through C. C was shared here, but not here. E, and I just went through each set. And then beyond that, I wanted to make sure that every element in the universal set was in the Venn diagram. And I found that B did not live in any of these sets. So it has to go out here outside of everything. And then that's going to help you answer the questions below. So A intersects B. I think earlier I just showed here, but it's actually this whole piece here. A intersects B. So where they have elements in common are A and C. The complement of A is everything not in A, which means all of this stuff out here, not in A. So remember that all of this is an A, so we don't consider any of those. So F, D, I, and B are not in A. B, D, F, I. And then last one, A union B, that's where we take all the elements of A, we union them with B, and we just list them out. So we've got A, I'm trying to put them in order, C, E, F, oh, I forgot D. D, E, F. I'm going to highlight this so I can see it better. A union B. There we go. I've got A, C, D, E, F, H, and J. And that's all. That's how you do operations on sets. That's it for this lesson. I hope you enjoyed it. If you have any questions, please let me know and I'd be happy to help. See you in the next one.